Welcome back to the GCSE Maths Pro YouTube channel. Today we're going to be starting the topic of inequalities, and specifically part 1 is solving linear inequalities. As you can see, we've got 4 parts to this topic. However, I do want to highlight the fact that the last 2 parts are higher tier only. Okay, so if you're doing foundation tier, you only need to look at the first 2 of these videos, then ignore the rest. Okay, so solving linear inequalities, well, linear anything really to do with algebra, is the fact that we've just got x to the power of 1, isn't it? Or any letter to the power of 1. When we say linear graphs, we're talking about straight line graphs, aren't we? The ones where it's y equals mx plus c. It's just x to the power of 1, isn't it? When we're solving linear equations, so we're going to deal with linear inequalities in the exact same way that we deal with linear equations. Now, you've got 2 options here, so we're going to solve it in the same way. You might prefer to leave the symbol there, just kind of ignore it for now and work through it the same. You might go, do you know what, that's a bit confusing, I'd rather just write it as equals and then put the symbol back at the end, but obviously don't forget to do that, right? Otherwise they will mark it as wrong. So, for example, you could write it as, okay, let me just imagine for now that I'm dealing with 2x equals 18, because you might then be more familiar with how do I normally solve that? Ignore the concept of inequalities. How would I normally solve this? Well, solving means I need to get x on its own, isn't it? I need to get x on its own on one side. Currently, with this example, the 2 is in the way, isn't it? We don't want 2x, we just want 1x. We're going to deal with it in the exact same way. So, if we just had this as a linear equation, to move the 2 to the other side of the equation, we would have to do the opposite of what's already happening, wouldn't we? What's happening currently is we've got 2 times x. The opposite is therefore divide, isn't it? And the same with linear equations, we have to do it to both sides. So 2x divided by 2 is just obviously 1x. 18 divided by 2 is 9. If that was just an equation, that would be your answer, wouldn't it? X equals 9. However, remember, it is an inequality. So, if you have decided to put the equals there instead, whilst you solve it, just remember to put the same symbol back. So, actually, in terms of an inequality, x is less than 9, isn't it? The inequality symbol will always face the bigger value. So, x is obviously smaller than 9. Okay, so that is how you solve it. That's literally it. Obviously, you might be happy just to leave the same inequality symbol, but just pretend it's an equals. That's probably easier so you don't forget at the end. But you've got those options there. Okay, so deal with this in the exact same way, right? I'm going to use the equals symbol for this one as well, just so you can see. It's basically the same as having 4x minus 12 equals minus 4. This one we have 2 steps, don't we? Because we've got 4 and 12 that we need to move to the other side just to get x on its own. So I would probably move the 12 first. It's currently minus 12, so the opposite is plus 12. Apply that to both sides, so you've got 4x minus 12 plus 12. Well, obviously the 12s cancel out, that's the whole point. Minus 4 plus 12 is 8. Now I just need to get rid of the 4, don't I? So, because we said before, obviously 4x is 4 times x, I need to divide by 4. I get just 1x equals 8 divided by 4 is 2. It's literally the exact same thing, but obviously don't forget to put that symbol back. So my final answer is going to be x is greater than or equal to 2. Okay, again, the symbol faces towards the bigger value. So in this case, x is greater than 2, isn't it? And this extra line means or equal to 2. So just imagine you've got linear equations, just normal equation. Solve it how you normally would, but just remember to keep the symbol there, okay? Okay, this one's very similar. Give this one a go, pause the video, and then play it when you're ready to check your answer. This one I'm going to leave the symbol as it is because that's what I would personally do if I was to do this exam. So, I do know though that I'm going to move the 5 first. It's currently plus 5, so I need to do the opposite, which is minus 5. I get 12x left there is less than or equal to 29 minus 5 is 24, isn't it? Now the 12, well, I obviously need to divide both sides by 12. So I get just 1x is less than or equal to 24 divided by 12 is 2. Now I've pretended that it's an equal sign, so I just do the same thing, but I don't have to then remember to put the correct symbol back because I never changed it in the first place. Okay, so it's up to you if you want to put the equals there to make it look a bit more obvious and then change it back, or if you'd rather just keep the same thing but remember the fact that you can deal with it in the same way as if it were just a normal equation. Okay, this one, however, we need to have a look at. This is the one occasion where solving inequalities is not the exact same as solving linear equations, okay? We've got kind of two options here I'm going to show you. So I'm going to draw a line down the middle to give you both options. Option 1 is, the only thing that's in the way is the -8, isn't it? Not just 8, but -8, because when you solve an equation and an inequality, we don't just want -x, do we? We don't want to just move the 8, we need positive x. So option 1 is divide by -8 on both sides. So -8x divided by -8 is obviously just positive 1x, because the negatives cancel out. Then 56 divided by -8, well, positive divided by a negative is a negative, and obviously 56 divided by 8 is 7. Now, I've obviously paused on putting the symbol here because this is where we need to note. If you're multiplying or dividing by a negative number with inequalities, you have to flip the symbol. So do you see how the symbol was facing towards the x? Well, because I've divided by -8, I have to flip it. Okay, so that's the only thing you need to remember where it's different. Because obviously with an equal sign, with normal equations, there's, the equal sign doesn't flip, does it? It's not going to change anything. But with inequalities, it's very important which way the symbol faces. Okay, so you have to flip it. Now, personally for me, I like to just avoid that completely. I just don't want to deal with it. So what I do, and you can decide between these two options, let me just copy the same question over here. Personally, and I do this with equations as well, to be fair, not just inequalities, you can actually move the x itself, right? This is -8x. I would actually just add 8x to both sides, and that would move it across, wouldn't it? Now, because I'm adding it, that's not going to change anything, so that becomes 0. See, cancelled it out. Then I've got 8x plus 56. Now, I would then just subtract the 56. Now, you might think this is kind of just beating around the bush, really, like, we're going around all the houses. Fine, do the first one and just remember to flip it. That's on you, but I probably just remember basically, so I'm not going to risk that. I'd rather do a few extra steps just so that I don't forget. So I've got -56 here, okay? The symbol is still the same way because I've not divided or multiplied by any negatives. And now do you see how I just need to divide by 8? I'm not dividing by a negative or a positive, I'm just dividing by 8. It's already -56, so divided by 8 is -7. Now, yeah, the x is on the different side to how it was. It doesn't really matter which side the x is on, as long as the symbol is correctly facing, okay? This is exactly the same thing. I know it looks different, but the symbol is still facing the -7 either way, isn't it? X is still less than -7. So you've got two options. I know this one looks a lot longer. I just prefer it because obviously I wouldn't write it out fully like this. I would just literally swap the 8x and the 56 and know that they would swap. I would kind of just make that leap in my head without writing it down. But it's up to you, okay? On this side, you have to remember to flip the symbol. Okay? If you're going to do it this way, the first option, if you're going to divide across by -8, if that feels just easier, that's absolutely fine. But you have to remember, don't risk it. You have to remember, multiply or divide by a negative, you have to flip the symbol. If you know that you're going to remember that, perfect, do it this way. It's much simpler, obviously. If you're not sure you're going to remember, or you feel like that's going to get just lost in translation at some point, I just do this because, to be fair, I naturally do this with equations as well. That's just how my brain works, right? I just like to just add it to the other side to make it not be a negative anymore, right? The x, I like to add to the other side to move it. That's just my personal preference. You get to choose. A lot of the time with algebra, you kind of have two options and you just get to choose which is easier for you, okay? It's not a right or wrong situation. We've still got the same answer. Just choose which one works for you, okay? So otherwise, other than this, solving linear inequalities is exactly the same as solving linear equations. This is the only time where it's just something different, okay? Okay, so let's try this one. This one actually also has two options, not anything related to the previous question in that sense, but you can either expand the brackets and then move it, move across from there, or because I know that 30 will divide by 5, I could just divide by 5 straight away, couldn't I? Because I know that when I've got brackets like this, I've got 5 times x minus 1. So it's up to you. I'm going to expand it just so you can see the full method, but if you want to just straight away divide by 5, that's the faster way. So let's say we were to expand it. So 5 times x is 5x. 5 times minus 1 is obviously minus 5. Keep the same symbol, and then 30. And then we're just back to the same thing as before, so I need to add the 5 to move it across. I've got 5x is greater than or equal to 35. Then I divide by 5. So you're dividing by 5 at some point. Just depends when you'd like to do it. So that gives you 1x is greater than or equal to 7. Now this one I didn't swap the symbols, did I? I didn't flip the symbol, because obviously I'm dividing by a positive number. Doesn't make any difference, okay? Okay, so this is basically the same question again. So pause the video if you want to give it a go, and then check your answer afterwards. So as I said before, we've got two options again. You can expand the brackets and then go from there. Or if you want, you can just directly divide by 2, and then you won't have any brackets to expand, so it's a bit faster if you want to do that option. But whichever makes more sense to you and whichever you think you're more likely to get the correct answer with. So I'm going to give you both options, that's why I've drawn this line here. I'm going to show you both options so you can see exactly how it comes out as the same answer. So let's say if we expand first. 2 times 3x is 6x. 2 times 4 is plus 8. Is less than minus 34. If I move across the 8, I have to subtract it, don't I? So minus 34, take away another 8, is going to give me minus 42. Then all I need to do is divide by 6, and I will just have x on its own, which is less than minus 42 divided by positive 6 is minus 7. Okay, that's fine. Let's say though, if I were to not expand the brackets and just divide across by 2 in the first place, I'm going to copy out the question so you can see it here as well. The reason why we divide by 2 is because it's obviously 2 times by the brackets, isn't it? 2 multiplied by 3x plus 4. So what I can do is the opposite of that. So I can divide by 2 on both sides, which gives me just 3x plus 4. That just opens up, which is less than minus 34 divided by 2 is minus 17. And then all I need to do is minus the 4. So I've got 3x is less than minus 17, take away another 4 is minus 21, and divide by 3, you can see we're going to end up with the same answer. So minus 21 divided by 3 is minus 7. Exactly the same thing. It really is, there's not a right or wrong answer in terms of the way that you do it. Obviously, as long as you get x is less than minus 7, you've done exactly what you need to. So you just choose whichever you prefer. This can also come up as well in equations, not just related to inequalities. You might have an equation that you need to solve where you've got expanding brackets like this, and you can just divide by the number in front if you like. Completely up to you. You make the decision as to what works best for you. So this next question you can see we've got solve 6x minus 3 is greater than 2x plus 9. The only difference here is we've got x's on both sides, and that can also happen with equations, okay? So I know a lot of students get thrown off by this and go, what do you mean I've got x's on both sides and all that? It's fine. What we want to do is before we start trying to get x on its own, we need to get both of those x terms together on the same side in the first place, don't we? So you can choose whichever one you want to move. I'm going to move the smaller one, because given that they're both positive, I'm going to have to subtract one of these, aren't I? Either 6x or 2x to move it. I'm going to choose the smaller one because ideally I want to keep x as a positive, don't I? So I'm going to minus 2x from both sides. As you've seen before, you can move the x's as well. You can move the letters, that's fine. So 6x minus 2x is obviously 4x. The minus 3 is still there because that's not a like term, so it's not affected. 2x minus 2x obviously cancels, and then we're left with the 9. So now it looks as just the same as before, doesn't it? That's all you have to do is get, if you've got two x terms, one on each side, just get them together. Move one of them to get them together. Now we're going to obviously then just carry on as normal. So add the 3 and 3. So that gives me 4x is greater than 12. And then divide by 4. So we get x, I'll write it over here, x is greater than, and then 12 divided by 4 is 3. Okay, that's it. X is greater than 3. Okay, this is exactly the same question, so try this one out yourself. Figure out which of the two x terms you're going to move and obviously how you're going to move it. So I'm going to also move the smaller one in this case because we've got minus x, which is minus 1, effectively, isn't it? So if I add it to the other side, this number of x's is still going to be positive. Ideally, I want to keep the number of x's positive, just because it's easier, isn't it? Then I don't have to divide by negative and flip the symbol and all that mess. You can move whichever you want. There's not a right or wrong answer, but I think it's easier to add the x in this case to keep everything positive. So 9x plus x is 10x. Still got 27 there, is less than. Now, don't make the mistake of writing 18 because technically it's minus 18, isn't it? That's still negative there. So negative 18. And again, we're just back to where we were before. So I'm going to take away 27. So taking away an extra 27 is going to give me minus 45. And then divide by 10. This is an example where you can see you're not always going to get a whole number, okay? It might be that you get a decimal or a fraction, absolutely fine. Again, I'm going to write it here. Obviously, 10x divided by 10 is just 1x. Is less than minus, still a minus because we're dividing by positive, so negative divided by positive is still negative. 45 divided by 10, you can put it as a fraction if you want, or you can just write 4.5 because that's a fairly easy decimal. So that's fine. X is less than minus 4.5. That's absolutely fine. Okay, the second half is if you've got inequalities where you've got two symbols. Okay, so there's technically like 3 parts to this inequality, aren't there? Still the exact same thing, okay? We're still going to do exactly the same thing, but obviously whatever you do, whatever action you do, you need to apply it to all 3 parts, not just 2 of them. So this time we want to get x, obviously it's in the middle, that's fine. You want to keep it in the middle, but you want it on its own. Okay, we don't want 3x, we just want x, 1x. So solve minus 9 is less than 3x, which is less than 24. In this case, it's just the 3, isn't it? The 3 that's in the way. And because we want 1x, not 3x, we just want to divide by 3. So just go through and divide everything. Minus 9 divided by 3 is minus 3. Same symbol because we haven't divided by a negative. 3x divided by 3 is obviously just 1x, which is what we want. Again, the same symbol. 24 divided by 3 is 8. That's it. That's your answer there. Exactly the same. Just do it to all the terms. Okay, divide by 3 in this case to all of the terms. Nothing else. Okay, try this one out yourself. Remember, just whatever you're going to do anyway to get the x on its own in the middle, just apply it to all the terms. So solve minus 16 is less than or equal to x minus 6, which is less than or equal to 2. In this example, the issue is the 6, isn't it? We don't want x minus 6, we just want x. So we have to do the opposite, which is add 6, and we're going to add it to everything. Minus 16 add 6 is minus 10. Same symbol because we haven't multiplied or divided by a negative. X minus 6 plus 6 is obviously just x, that's the whole point. And then 2 plus 6 is 8. That's your answer, that's literally it. Okay, this one you can see we've got 2 parts. Okay, we've got the minus 2 and the 8. But also you can see there's a slight issue because we've got a minus 2x. We obviously want positive x. Okay, so just be aware of that. So for me, I'm going to move the 8 first. It's currently plus 8, so I need to minus 8 from everything. Now, this is 0, so 0 take away 8 is minus 8. Same symbol, minus 2x plus 8, minus 8 is obviously just minus 2x. Same symbol again, 10 minus 8 is 2. Now, though, you can see we've got the issue, because we have to not only divide by 2, we need to divide by minus 2, don't we? This one is not that we're going to move the x somewhere. This one I would just divide everything by minus 2, okay, because it's a range. It's in the middle, isn't it, the x? So just divide everything by minus 2, but remember we said dividing or multiplying by a negative means you have to flip the symbols. So minus 8 divided by minus 2, well, first of all, that's a double negative, isn't it? So that would become positive, but also 8 divided by 2 is 4. Flip the symbol to face the 4. Obviously, minus 2x divided by minus 2 is just 1x, isn't it? Again, double negative makes it positive x. And then flip the symbol again. 2 divided by minus 2, well, a positive divided by a negative is a negative. And 2 divided by 2 is 1. You can see here it makes sense why we would flip the symbols. Because 4 is obviously bigger than minus 1, isn't it? Right? And we've got, obviously, the symbol has to face towards the bigger value. If I left it where it was, let's say if we left it the same direction, This doesn't make sense, does it? -1 is not bigger than 4. It doesn't make sense, okay? So they flip the symbols. What I would do though, because it does look a bit odd having the symbols facing the left, doesn't it, when it's in a range particularly, I'd probably just rewrite it, obviously put the smaller number on the left and the bigger number on the right, but it doesn't really technically matter, right? So that's your answer. X is somewhere between -1 and 4. Okay, this is our last question. Try this one out. Same thing again though. So I would move the 2 first, add 2 to both sides, well, to all 3 parts. -8 plus 2 is -6. Keep the same symbol. We haven't multiplied or divided by a negative. We're just left with 4x in the middle because obviously those 2 should cancel out. 6 plus 2 is 8. Okay. Now we want to divide by 4, don't we? Divide by 4. As we saw in another example, you're not always going to get a whole number. So you can see here we've got 6 over 4, just 1x, and 8 divided by 4 is 2. Now either with this side you can either simplify the fraction and leave it like that, or put it as a decimal. I'd say if it's not a recurring decimal, that's fine. If it's a decimal that's got loads of numbers just going on and on, obviously just leave it as a fraction. So you can either leave this as -3 over 2, that's the most simplified, or obviously 3 over 2, 3 divided by 2 is 1.5, isn't it? So you can just write it as -1.5 if you would prefer. Okay, so that's absolutely fine, either of those 2 answers. Okay, so that is everything on how to solve linear inequalities. You're going to need that again if you are foundation or higher tier. Definitely make sure you're happy with this video before you start looking at inequalities on a number line, which is the next video, because the second half of that video is based around solving inequalities as well, okay? So you will need this video to then proceed to the next. As I said before, you can see the last 2 videos are higher tier only. Okay, so the next one is fine for foundation tier, but the ones after that are higher tier only, so just leave it there if you're only doing foundation. So thanks for watching this video on solving linear inequalities. If you have any questions, please leave them down below in the comments. Definitely check out the next video in the series, which is showing inequalities on a number line.